Welcome to part 2 of our lesson on the quotient rule. So this video is just essentially going to be some examples using the quotient rule. So we'll start with the quotient. F at t equals t to the 2 plus t divided by t to the power 4 minus 2, and we're going to find the derivative. So f prime at t. T is our variable. So you're going to need to recall the quotient rule. If you remember, the quotient rule was that you do the derivative of the numerator. So take the derivative of t squared plus t, which is 2t plus 1, times, you leave the bottom, so times the bottom function, or the denominator, minus, leave the numerator, so leave the top, times the derivative of the bottom. So that'd be 4t cubed, and that's all over the bottom, t to the 4 minus 2, all squared. Okay, so that's the derivative right there. You've applied the rule. Now, often you will simplify that numerator. So expand, collect any like terms. So we would get expanding this binomial, t2 times t to the 5 minus 4t plus t to the 4 minus 2 minus, and then I'll expand this. Oh no, I don't want to do that. Control. So just expanding this, I get 4 t to the 5 minus 4 t to the 4, all divided by t to the 4 minus 2, all squared. Collecting like terms, we got a t to the 5, so that'd be minus 2 t to the 5, t to the 4, we'd have minus 3 t to the 4, minus 4t minus 2, all divided by t to the 4 minus 2, all squared. Okay, so that's good. That's the derivative. F prime at t. You might ask, like, should I factor that? If it's an easy thing to factor, and there's obvious factors maybe, but I mean, this is a fifth degree polynomial. That's not an easy thing to factor, so I would say no, you do not have to factor this any further. Okay, here's another one. F at x equals 3x cubed minus 2x squared, all divided by x. So let's do this again. I didn't write differentiate. Here, differentiate. That's the question, or what we're supposed to do. And so f prime at x would be the derivative of the numerator. So it would be 9x squared minus 4x times the denominator, which is just x, minus, leave the numerator, times the derivative of the bottom, which is just 1, derivative of x is 1, all over the bottom squared. We'll expand that numerator, so 9x cubed minus 4x squared minus 3x cubed plus 2x squared, all over x squared. Collecting like terms, what do we got? We got 6x cubed minus 2x squared, all over x squared. So here there's an obvious factor on the top, right? You can factor out a 2x squared from the numerator, and you'd have 3x minus 1, all over x squared, and then x squared and x squared are common factors. So you have 2 times 3x minus 1. So that would be the derivative of the original function, which was this. Now, some of you might have looked at this and said, why would you do the quotient rule when you could just simplify first, or reduce? Simplify or reduce, whichever you want to call it. So if I were to reduce that, notice there's a common factor of x on the numerator. So x, so we have 3x squared minus 2x, all divided by x. Those go away, so f at x is actually just equal to 3x squared minus 2x, as long as x does not equal 0. Remove over a bit. And then to do the derivative, it's just derivative of a simple polynomial. So that's 6x minus 2. So x does not equal to 0, and then if you want to factor that, 2, that'd be 3x minus 1, as long as x does not equal 0. So notice that's the same, this derivative, which we got, is the same as the derivative we had over here. So essentially the reason I showed you this example was to show you that when using the quotient rule, it might be best to simplify first. Okay, so don't go straight to the quotient rule unless you've already tried simplifying. So that's the moral of this derivative. Simplify before you take a derivative. Okay, third example, we want to look at this function and determine all points with horizontal tangents. So dy by dx. Well, before I take the derivative, talk about how we're going to answer this question. So horizontal tangents, what does that mean? That means slope of tangent is 0, right? Horizontal tangent, horizontal line has a slope of 0. And what does that mean? Slope of tangent is 0 means that the derivative is 0, or dy by dx equals 0. So what we're going to do is determine dy dx and set it equal to 0. So this one, quotient, we're going to have to use a quotient rule. You can't simplify this. Well, you could, but it's not going to help very much. So take the derivative of root x. So that'd be, remember root x is x to the power of a half. So it'd be 1/2 x to the power of negative a half times the bottom. So derivative of the top times the bottom minus, leave the top, times the derivative of the bottom, which would just be 1, all over x plus 1 squared. So now we want to let this equal 0, so dy dx is equal to 0. And when you're solving a, when you're solving an equation, when you're solving a rational equation, and the rational is equal to 0, really just the numerator is equal to 0. Right? Because if the numerator is equal to 0, then the whole thing is equal to 0. So I'll just put that x to the minus half on the bottom. And then I don't care about the denominator. Well, again, this is really rational, right? So I'll get a common denominator here. So I'll have x plus 1 all over 2 root x, right? X to the half is root x, minus, and then I want to get this over 2 root x, so I'll have to multiply this times 2 root x. So that would be 2x. 2 root x times root x is 2x. So 0 equals, and then again, I just care about the numerator. So x plus 1 minus 2x, and you can think of it as multiplying by 2 root x, or whatever. So 1 minus x, so x is equal to 1. So what that tells me is that when x is equal to 1, the slope of the derivative, or the slope of the tangent, the derivative, is equal to 0. So when x is equal to 1. Now the question actually asked me for the points, and this is just the x value of the point. So in order to get the actual point, I would sub x into the equation. So remember, y equals root x over x plus 1, and then we'll put x equals 1 in there. So that'd be 1 over 2. So therefore, the point with the horizontal tangent is 1, 1/2.